Students often get confused after learning effect modification because it's hard to differentiate what is confounding and what is effect modification. And I'll show you some stata output, which will help you appreciate the differences between these two concepts. They're totally different things. And we can think about effect modification is the idea that the effect of some variable is differential depending on some other variable. Here's some data about social competence and obesity in elementary school. And they're looking at how does obesity affect a kid's social competence. Now, you might hypothesize that for boys and girls, the effect of obesity might differ. For boys, being bigger, being stronger, things that come along with obesity, those actually might be a benefit for a boy to be one of the biggest, strongest kids in the class or on the sports team or whatever. For girls, that might not be the case. So these researchers have a data set and they're looking at how is obesity related to social competence, and is that differential between boys and girls? And they say here, we tested all the models for an interaction by gender, but it was not significant. It's the same. The effect of obesity on boys and girls and how it affects their social competence is the same for boys and girls. So what they did is they combine the two data sets. Now, when you see effect modification, we already saw you have to stratify out and say, well, for boys, it does this. And for girls, it does this. For houses over here, it does this. For houses over there, it does this. You have to get practice in thinking about what statistic answers my research question. And the most important thing you can ask anybody is, what is your research question? What is your research question? If somebody says to you, how is gestational age related to birth length after adjusting for preeclampsia status? This part right here tells you there's some concern, there's some interest about confounding, that we want to adjust for some other variable or control for it. Now, the way this question is set up, birth length is our outcome. We're looking at how does gestational age affect birth length. So we're going to have gestational age, and we're going to be interested in the slope. And they're worried about this as a confounder, so we have to include that other variable in the model. So this is a research question that's about the independent effect of one variable after controlling for another variable. And we set it up and we pull out that slope and we look at that p-value. Now I'm going to show you another research question, and at first glance it might look exactly the same, but it's totally different. This research question is, does the effect of gestational age on birth length depend on preeclampsia status? And what that's really asking about is effect modification. Is the effect of this first X on Y, does it depend on your second X? And the only way you can answer that is to fit an interaction term into the model. We saw in Stata you can use these double hashtags to put the two parent terms of the main effects, and then Stata will generate that interaction term, and it will tell you, is it statistically significant or not? The null hypothesis is that it is 0, and we see this is actually pretty close to 0. We have no evidence that that is significantly different than 0. So we can say we have no evidence that the effect of this on this depends on some other variable. In other words, the slopes are parallel. The slopes are the same. It's really important to understand that distinction between confounding and effect modification. You see all sorts of examples of effect modification in the news and in the medical literature. For obese, stress may be even more deadly. Stress is deadly. For some people, it may be even more deadly. The interesting question then becomes, why? Well, there's a biological phenomenon. At the point in time that I'm recording these lectures, everything seems to be explained by IL-6. Maybe there's a new inflammatory something in the future that everyone goes to. Why? Why? That is the mechanism, something in the real world that causes the effect to be differential. Mood affects young and old differently. When something happens, there's something in the changing nature of the mind and the way it handles emotion, that an input on younger people causes a differential effect than the same input on older people. All sorts of interesting examples on this. Vitamin E. Vitamin E might be good for you unless you are a smoker, in which case it is bad for you. Heterogeneity of the effects. We find these things by exploring and testing for effect modification. But it might be the case that the research question itself might be, is there effect modification? Folate in cancer. Folate supplementation might be good to help you prevent cancer. But once you have cancer, folate supplementation may increase the speed at which the cancer develops. Modification of the outcomes. Now, what's interesting is that a lot of these studies a lot of these investigations are done kind of post hoc. Let's look around and see if there's any effect modification. And you might not have enough power to detect any of that stuff. So again, be careful. There might be type 2 errors when people are investigating to see if effect modification exists. That is a quick overview of confounding versus effect modification. You'll spend a lot more time talking about this in epidemiology, and you'll wrestle with this throughout your career as data analysts, throughout your career as public health professionals, when you try to really figure out how we can look at the distribution, determinants, and deterrence of disease in order to really bring about positive health outcomes. Thank you.